In this video, we're going to learn how to rationalize the denominator. And rationalizing the denominator means making sure that there's no root in the denominator, so change it from an irrational number, which has the root, to a rational number. So it's called rationalizing. And simplified form should never have a root in the denominator. So to rationalize, we need to first remember that root 2 over root 5, well, we can say that's root 2 over root 5 written this way rather than the root of everything. And that's a rule because we're dividing, we can take the root of the top and the root of the bottom. And remember, we can always multiply by 1, but we're going to choose 1 and write it as root 5 over root 5, because this is equal to 1. But what happens when we multiply root 5 and root 5? That gives us root 25, and root 5 and root 2 gives us root 10. And when we simplify that, that leaves us root 10 over 5. And so we have a rational number 5 in the denominator, or the denominator has been rationalized. And really we just do this so that if we have to add and subtract these, it's easier to make a common denominator with a rational number than an irrational number. In the next example, we can actually simplify the denominator first, and we can say that, well, this is 5 over 3 root 2, or root 9 times root 2, which is 3 root 2. Then we want to get rid of the root 2. So again, we're going to multiply by 1, but this time we're going to write it as root 2 over root 2. On the top, we get 5 root 2. On the bottom, we get 3 multiplied by root 2 times root 2. So let's write that out. That's 3 times root 4. Root 4 is 2, so that leaves us 5 root 2 over 3 times 2, or 6. And so that's rationalizing the denominator. Notice we're dealing with division only, so these rules are working. And if we look at 2 more here, now we have a cube root. We can still rationalize. So cube root of 2 over cube root of 3. But now we need to multiply by 1 to make the denominator a perfect cube. So cube root 3 over cube root 3 is not going to help. We need cube root of something over cube root of something. 3 cubed is 27, so somehow we need to make this 27. And to do that, we need to multiply by 9 over 9. And that's going to give us cube root of 18 over the cube root of 27. But the reason we chose 9 was because the cube root of 27, well, that's simply 3. And again, we've rationalized the denominator. Final example here. As soon as you see it, you should hesitate because you see there's a plus sign between them. We cannot break open a radical sign when we have that plus there. So the first thing we need to do is combine those two terms. So the lowest common denominator here, and we should remember this from previous work, is going to be 2a squared b squared. And so when we combine them, we're going to get all under the radical b squared plus 2a squared all over 2a squared b squared. Now we still have a plus sign, but we do have the division of two things. So now it does fit the examples above, where we can take the radical of the numerator, or the square root of the numerator, over the square root of the denominator. I'm going to do this a little quickly here. When we take the square root of the denominator, we get the square root of 2. The square root of a squared, well, that's just a, so we're going to take a outside. The square root of b squared, well, that's also just b, so we take that outside. So there's the simplified form, but we have a root in the denominator, so we have to get rid of that. So we multiply by root 2 over root 2, leaving us on top. Well, the roots have the same index, so that can go inside. We get 2b squared plus 4a squared all over. ab stays. Root 2 times root 2 is simply 2. Or square root of 4, which is 2. And the a, b stay. And so there's the simplified form, for example, d. A little bit more work because of the plus, so make sure you apply the rules correctly. Otherwise, rationalizing, just get rid of the roots in the denominator. So hopefully you understood those examples. In the next lesson, we'll continue with some more work with radicals. If you have any questions, come see me, get help as soon as you can, and we'll see you in the next lesson.